Hi, I'm Bruce Hollands, Executive Director of the PVC Pipe Association of North America. Thank you very much, Anya. Regarding the status of water infrastructure in North America, the water systems are in a state of crisis right now. A new study that came out a couple of weeks ago from the Utah State University Buried Structures Laboratory, one of the foremost organizations in the world with expertise in evaluating underground water systems and different forms of infrastructure that are buried, determined that 41% of the installed pipes are failing over 40% break rates compared to 6 years ago. And this is very important because 40% of the installed piping is now in a state of very serious disrepair. And if we don't start doing something about it, replacing it, then there could be a point where we're going to have exponential decline of these systems. In other words, you could see some social and serious economic disruptions because of these pipes that are going to start breaking at a much higher rate going forward. Well, what's causing the problem? You've got two main pipe materials that are no longer manufactured, cast iron and asbestos cement. Both of those materials have a tendency to corrode. They're corrosion-prone materials, so they're materials affected by corrosion, and corrosion eats away at these pipes and they start breaking, and that's essentially the main issue. We have to stop using materials that corrode in our underground pipe infrastructure. How that impacts water going through those materials is that water quality suffers. In fact, what they found is that with older cast iron piping materials, you have water quality issues such that pathogens can form and stay in those pipes and affect the health of people. You also have water quality issues in terms of discoloration that can occur. You need to use phosphates, orthophosphates, to mitigate the corrosive effects inside those pipes, which then leads to algae blooms and other environmental issues in the environment. So there's a host of issues when it comes to corrosion-prone materials. Yes, sustainability is a really important way to look at water systems, and when it comes to sustainability, PVC pipe is the best material compared to the other competitive materials out there in the marketplace. It requires the least amount of energy to manufacture. It lasts the longest by far because it doesn't corrode. Right now, current estimates are 100+ years for PVC pipe infrastructure. We just spoke with a world expert on that a couple of weeks ago, and he said it could even be hundreds of years, these materials. We don't know yet because we've only evaluated them in the last 60 years. And in those 60 years, we pulled pipe out of the ground, and that pipe has been tested. It's met the identical specifications as when it was manufactured. So extrapolating from 60 years of perfect performance, the experts are saying easily 100+, but beyond that, it could be hundreds of years. Wintertime is a time where water main breaks increase. And you know, the material that's being affected again by those breaks is iron pipe. Iron piping is very rigid. So when the ground freezes and thaws, it moves the pipe around and it cracks that pipe. And then you end up digging holes in your roads. And one of the problems, so yes, it slows things down. If you look at Montreal, very severely impacted by iron pipe breaks throughout the city. And sometimes I've been through that in Montreal, and it looks almost like a war zone. The infrastructure there is in very bad shape. And PVC, with materials like PVC, which are flexible and move with the ground movements, they don't break. And so again, there's another solution that PVC brings to the table, is a piping material that can deal with the rigors of wintertime. You know, a similar thing happens in the summertime in parts of the United States where it gets very dry. The ground loses its moisture and contracts, and also then breaks the pipe, just like thaw and freeze cycles do. Water main breaks can vary in cost between thousands of dollars and hundreds of thousands of dollars, depending on what's breaking. If it's a big water main, which is bringing water supply to a whole segment of the city, it could be $300,000, $500,000. I mean, these are very serious, disruptions when these pipes break. So right now, the current estimate is that to fix all the pipe in North America, you're looking at about $2 trillion. $1 trillion for water pipe replacement that's needed, and another $1 trillion for all the sewer pipe to be fixed in North America in the next 20 years. In terms of water main breaks annually in North America, you're looking at anywhere from 250,000 to 300,000 breaks every year. And it's in the billions of dollars in terms of those costs, and to fix those every year. And we're not even including the disruptions to the economy and people's lives. We're just talking about the money it takes for the city to replace those. So it's a really big problem. And again, the reason those things are happening by and large is because of corrosion-prone materials. And without corrosion, you don't have those problems. A vinyl pipe can be recycled. They've done some tests in Europe up to 8 times into itself. So in other words, if you were to remove it from the ground where it was previously used and recycled it and made new pipe, you could do that up to 8 times. There'd be no change in the material properties of that piping material. They've done it 8 times, and the pipe is as good as new after 8 times. Well, I think, you know, we've talked about the performance of PVC piping, vinyl piping in the ground. It's the you know, it lasts over 100 years. It doesn't break as much. In fact, the recent study from Utah State shows that it has a break rate 2.4 times less than new iron pipe called ductile iron pipe. And also, here's the real, to me, you know, the most promising component. When you look at this $2 trillion of needed pipe infrastructure investment over the next 20 years, PVC pipe's up to 70% less expensive on top of that. So you've got a better performing product, and it's less expensive, and you're in a situation right now where governments don't have as much money as they had in the 60s and 70s. So to me, the value proposition is very clear. You've got to use more PVC in these water systems, and it's going to help fix them for future generations and make them more sustainable, because in 100 years from now, they're not going to be breaking because of corrosion.